Hello, my name is Nisha and I will be presenting the topic Introduction to Hadoop for Big Data Processing for the next few minutes. At the end of this session, viewers will be able to explain big data and its characteristics, describe the architecture of Hadoop, and explain the Hadoop distributed file system. We'll now see what big data is. Big data is a collection of data sets so large that they exceed the computational capacity of conventional database systems. Big data mainly comprises of structured data and unstructured data. Structured data is machine understandable form, that is, they are easy to store, manage, query and analyze. For example, table. And unstructured data is non-machine understandable form, example Facebook comments, posts, etc. The structured and unstructured data gets created by various organized computing problems across a number of servers. The salient characteristics of big data are volume, velocity, and variety. We will see the first characteristic of big data, volume. We currently see that there is exponential growth in data storage as data is more than just text. Data is of various formats such as videos, music, and large images. Enterprises commonly have terabytes and petabytes of data. Original data is evaluated to get new information which causes data explosion. In olden days, all data was generated by internal employees, but nowadays, data is generated by employees, partners, and stakeholders. We will now see the next characteristic of big data, velocity. Initially, companies analyze data using a batch process. One takes a chunk of data, submits a job to the server, and waits for delivery of the result. Batch process can only be used if the input data flow rate is slower than the batch process time. There was a time when we used to believe that yesterday's data is recent, but today people reply on social media sites with the latest happening. Data movement is now almost real time and update window is just a fraction of seconds. We will now see the next characteristic of big data, variety. Data can be stored in multiple formats. For example, database, Excel, or it can be stored in a simple text file. Sometimes data is not of the traditional format we assume it would be. It would be in SMS, PDF, video, etc. Structure can no longer be imposed on data to keep control over analysis. Organizations need to rearrange it to make it more meaningful. It would be easier if data was in the same format. Introduction to Hadoop. Hadoop was created by Do Cutting. Hadoop is an open source software framework that is used for data storage and data processing in a distributed fashion. Architecture of Hadoop. The first component is Pig. Pig is a platform for analyzing large data sets that consist of a high-level language for expressing data analysis programs, coupled with infrastructure for evaluating these programs. In practice, Pig is a language that allows you to describe data sets stored as raw files, such as delimited text, and subsequently perform a series of operations on those data sets that are familiar to SQL developers. The next component would be Hive. The Hive warehouse software facilitates querying and managing large data sets residing in distributed storage. Hive is a language that allows you to put an SQL-like structure on top of data stored as raw files such as delimited text, then query data using Hive query language. hcatalog is a table and storage management layer for Hadoop that enables users with a different data processing tools such as Pig, MapReduce, and Hive to more easily read and write data. The hcatalog allows users with a relational view of the Hadoop distributed file system, so the users need not worry in what format their data is stored. MapReduce is a programming model and an associated implementation for processing and generating large datasets that are flexible to work on real-time tasks. MapReduce takes the input data and feeds each data element to the mapper. In the reducing phase, the reducer processes all the outputs from the mapper and arrives at the final result. In simple terms, the mapper is meant to filter and transform the input into something that the reducer can aggregate over. HBase is a distributed column-oriented database system that runs on top of the Hadoop distributed file system. A HBase system comprises of a set of tables. Each table contains rows and columns much like a traditional database. Each table must have a primary key and all access attempts to HBase tables must use this primary key. An HBase column represents an attribute of an object. For example, if the table is storing diagnostic logs from servers in your environment where each row might be a log record, a typical column such as a table would be the timestamp of when the log record was written, or perhaps the server name where the record originated. The Hadoop distributed file system. It is a primary storage system used by Hadoop applications. It is a distributed file system that provides high throughput access to application data, creating multiple replicas of data blocks and distributing them on compute nodes throughout to enable reliable and rapid computations. Hadoop distributed file system. The Hadoop distributed file system architecture mainly composes of two components, name node and data node. A HDFS cluster has two types of node operating in a master-worker pattern, a name node and a number of data nodes. The name node manages the file system namespace. Data nodes are the workhorses of the file system. They store and retrieve blocks when they are told to, and they report back to the name node periodically with a list of blocks they are storing. These are the replicas of data. The name node. The name node decides about replications of data blocks. The HDFS namespace is a hierarchy of files and directories. Files and directories are represented on the name node by inodes, which record attributes like permission, modification, and access times. The image contains metadata, that is inode data and list of blocks. At the local host, a persistent record of the image is stored, which is called a checkpoint. And modification log of the image called journal is also stored. During restarts, the name node restores the namespace by reading the namespace and replaying the journal. Data nodes contain data and metadata, that is checksum and block generation stamps. During connection to a name node, data node sends handshake to verify namespace ID and software version. If they do not match, then the data node automatically shuts down. The data node registers itself with the name node. The data node then stores their unique storage ID, which is used for internal identification for the data node. The data node sends block reports to the name node to identify its replications. Usually on normal operations, data node sends heartbeats to the name node so that the data node is operating and the block replications it hosts are available. The default heartbeat interval is 3 seconds. If the name node does not receive a heartbeat from the data node in 10 minutes, the data node is considered to be available and the name node blocks all its replications. To read an HDFS file, client applications simply use a standard Java file input stream as if the file was in the native file system. Behind the scenes, however, this stream is manipulated to retrieve data from HDFS instead. First, the name node is contacted to request access permission. If granted, the name node will translate HDFS file name into a list of HDFS block IDs comprising of that file and list of data nodes that store each block, and returns this list to the client. Next, the client opens a connection to the closest data node and requests for the specific block ID. The HDFS block is returned over the same connection and data is delivered to the application. To write data to HDFS, client applications see the HDFS file as a standard output stream. Internally, however, stream data is first fragmented into HDFS size blocks and then smaller packets by the client thread. Each packet is enqueued into a FIFO that can hold up to 5 MB of data, thus decoupling the application thread from storage system latency during normal operation. A second thread is responsible for dequeuing packets from the FIFO, coordinating the name node to assign HDFS block IDs and destinations, and transmitting the blocks to data nodes for storage. The thread manages acknowledgements from the data nodes to the data that has to be committed to the disk. Advantages of Hadoop. Hadoop is highly scalable as the nodes are spread across the racks and are connected by switches. The racks are connected through core switches. Hadoop is economically cheap as they use cheap commodity hardware. Fault occurrence is handled as the data node pings the name node at regular intervals, and there are replications of data blocks. Conclusion. Big data processing plays a very important role in today's world. Data is being analyzed for reasons other than it is originally intended for. Thus, Hadoop provides a cost-efficient, reliable, and scalable platform for handling big data. The Hadoop file distributed system also has a good way of handling fault occurrences. Below are the references for this presentation. Thank you for watching.